In this video, we will learn about pure and impure substance. Do you go to the market for shopping? If you look closely at the cartons of milk, ghee, juice, etc. that are being sold in the market today, you will find 100% pure or pure written on all the boxes. Can you tell us what is the meaning of pure? For ordinary people like you and me, if there is no adulteration in anything, then according to us, that thing is pure. But does the same thing mean pure things in the scientific definition? No. When a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance consists of single type of particles. So now you must be thinking, what are impure substances? The substances that are formed by mixing two or more pure ingredients are called impure substances. They are also called mixture. Let us now learn more about pure and impure substances by some examples. Let us take an example of salt. Is salt a pure substance? For this, we will first check whether salt is made up of the same type of particles. Here, you can see the particles of sodium chloride present in the salt. Are these particles identical? Yes. The composition of salt is composed of molecules similar to sodium chloride. Therefore, we can say that salt is a pure substance. Friends, we know that salt is made up of sodium chloride molecules. Can we separate salt into elements of sodium and chlorine by some physical process? No. Therefore, we can say that we cannot separate pure substances into other types of elements by any physical process. Can you think of examples of more pure substances? Yes, sugar, water, gold, diamond are examples of some more pure substances. Are the characteristics of 1 kilogram of sugar and 10 kilogram of sugar the same? Yes. From this, we can conclude that the characteristic properties of pure substances remain the same. Let us now look at the sugar and water solution. Is it a pure substance? Let us find the answer to this question by an activity. In a beaker, take this sugar and water solution and then heat it with the help of a burner. What do you see? Alright, sugar that was dissolved in water is separated from water due to evaporation. But can we separate sugars or water into their components by some physical process? No. From this activity, we can conclude that the solution of sugar and water is an impure substance or mixture, which consists of two pure substances, sugar and water. Can you think of more examples of impure substances? Potassium permanganate and water solution, tea, soil. These are some other examples of impure substances, which are made up of two or more pure ingredients. Friends, hope you have got a good understanding of pure and impure substances. In the next video, we will learn about the mixture and types of mixture of mixtures. In this video, we will study the types of pure substances. So far, we have studied substances and mixtures. But do you know that we can classify substances according to their chemical composition into elements or compounds? Let us first learn about elements. Do you know Robert Boyle was the first scientist in the world who first used the word element in the year 1661. Antoine Laurent Lavoisier, 1743 to 94, a French chemist, was the first to establish an experimentally useful definition of an element. According to him, element is the basic form of matter that cannot be divided into other simple substances by chemical reaction. Elements can generally be classified into metals, nonmetals, and metalloids. Let us first learn about some properties of metals. 1. They have a luster, shine. 2. Their color is silvery grey or golden yellow. 3. They are conductors of heat and electricity. 4. They are ductile and can be drawn into wires. 5. They are malleable and can be hammered into thin sheets. 6. They are sonorous, make a ringing sound when hit. Now you may be thinking, what can be the examples of a metal with so many properties? Gold, silver, copper, iron, sodium, potassium, etc. are examples of metals. And do you know an interesting thing? Mercury is a metal that remains liquid at room temperature. Let us now look at some properties of non-metals. 1. They display a variety of colors. 2. They are poor conductors of heat and electricity. 3. Unlike metals, these are non-lustrous except iodine. 4. They are not sonorous. 5. They are not malleable. Can you think of some examples of these? Examples of non-metals are hydrogen, oxygen, carbon, bromine, etc. And finally, metalloids are substances whose properties resemble both metal and solid non-metals. They are lustrous like metals. They are semiconductors of electricity. They are not tensile or malleable. Boron, silicon, germanium, etc. are examples of metalloids. Friends, do you know what we get when two or more elements combine? Let us understand this by an activity. Take 50 grams of iron powder and 3 grams of sulfur in 2 separate ceramic cups. Now mix iron powder and sulfur powder in the first bowl, and in the second bowl, mix iron powder and sulfur powder. Heat the mixture until it becomes red at high heat. Now remove the flame and allow the mixture to cool. Are the materials obtained in both cups similar in appearance? The gas obtained in a cup 1 is hydrogen. It is colorless, odorless, and flammable. While the gas obtained in cup 2 is hydrogen sulfide. It is colorless gas and smells like rotten eggs. Now check the magnetic properties in both cups. Bring a magnet near the material. Check if the material is attracted to the magnet. What do you see? The material obtained in cup 1 has magnetic properties, while the material obtained in cup 2 does not have magnetic properties. Although initially the given substances were similar, the materials obtained in both the cups showed different properties. Why did this happen? This happened because the action done in cup 1 resulted in the physical change of the substances, while the action in the cup 2 resulted in chemical changes in the substances. Material obtained in the cup 1 are two substances, a mixture of iron and sulfur. The properties of the mixture are similar to those two elements. The material obtained in cup 2 is a compound whose properties are completely different compared to combining elements. In this table, you can see the difference between a mixture and a compound. Friends, today we have studied the type about pure and impure substances. In this video, we will study about mixture and types of mixtures. We all feel very happy to take a walk on the beach, isn't it? Let us do an experiment with seawater. Let us take a little seawater in a beaker and heat it with the help of a burner. What do you see? Absolutely right. Sodium chloride dissolved in seawater is separated from water due to evaporation. Therefore, we can say that seawater consists of sodium chloride and water. However, sodium chloride is itself a substance and cannot be separated by physical process into its chemical constituents. Substances like seawater, which consist of more than one pure elements or compounds, are called mixture. Friends, are mixtures only liquids? Think. Since pure elements, solid, liquid, or gaseous, can be found in any of these states, mixtures can also be found in any of these conditions. For example, air is a mixture because it is made by mixing different types of pure substances and compounds such as oxygen, carbon dioxide, etc. Friends, seawater and air are both blends. But are their characteristic properties the same? Of course not. This is because they are made by mixing different ingredients. Different types of mixtures are formed according to the nature of the component. Let us now discuss the types of mixtures. We will learn about it through an experiment. Gather 3 of your friends for this experiment. Now, take 50 ml of water in 4 beakers. Suppose we name these 4 beakers as A, B, C and D. Now dissolve 1 teaspoon of sugar in A beaker. Tell your friend to dissolve 3 teaspoons of sugar in the B beaker. Now ask your second friend to dissolve 1 teaspoon of oil in the beaker C. And finally, ask the third friend to dissolve 1 teaspoon of sodium chloride and iron filings in the beaker D. Notice the texture of all the blends. Let us first look at the mixtures of beaker A and beaker B. What do you observe? Are A and B blends of the same texture? Correct. The types of mixtures in which the components mixed are uniformly distributed throughout the mixture is called homogeneous mixture or solutions. Mixtures A and B are both homogeneous mixtures made from the same component. But if we look at the intensity of the sweetness of the beaker A and B mixtures, we will find that they are different. As a result, we can see that homogeneous mixtures can have different composition. Now look at the mixtures of beaker C and D. Are these blends of the same texture? The components of mixtures obtained in C and D beakers is different physically. The mixtures which contain physically distinct parts and have non-uniform compositions are called heterogeneous mixtures. Can you think of examples of some more heterogeneous mixtures? Copper sulfate and potassium permanganate and water. Salt and sulfur and water. These are a few examples of heterogeneous mixtures. Friends, in this video, we studied mixture and types of mixtures. In the next video, we will study what are the solutions, suspensions, and colloids.